Welcome to doassignment-ca. Here is the problem. A 150-gram ball is kicked such that it leaves the ground at an angle of 60 degrees and strikes the ground at the same elevation a distance of 12 meters away. Determine the impulse of the foot on the ball. Neglect the impulse caused by the ball's weight while it is being kicked. Now, let us work through the solution step by step. We start by drawing the impulse momentum diagram. Before the kick, the ball is at rest, so its initial momentum is 0. The only impulse is from the foot, since we neglect the weight impulse during the very short kick. The principle of impulse and momentum then simply tells us that the foot impulse J equals the final momentum m times v2, and it points in the same direction as the launch velocity, which is 60 degrees above the horizontal. Now we do the kinematics to find the launch speed. The ball is a projectile launched at 60 degrees with initial speed v0. Setting the vertical displacement equal to 0 for the landing condition gives us the time of flight as 2 times v0 times sine 60 divided by 9.81. Substituting the time of flight into the horizontal range equation and using the identity 2 sine 60 cosine 60 equals sine 120, we solve for v0 squared. Dividing 12 times 9.81 by sine of 120 degrees gives 135.93, so v0 equals 11.66 meters per second. Applying the impulse momentum principle, the magnitude of the foot impulse equals the ball's mass times the launch speed, since the initial momentum is 0. Multiplying 0.15 kilograms by 11.66 meters per second gives 1.75 newton-seconds. The direction of the impulse is 60 degrees above the horizontal, matching the launch direction. As a verification, we split the impulse into its horizontal and vertical components. The horizontal component is 0.874 newton-seconds, and the vertical component is 1.515 newton-seconds. Combining them with the Pythagorean theorem confirms the magnitude is 1.75 newton-seconds, and the angle is indeed 60 degrees above horizontal. Both checks pass. To summarize, using the projectile range formula, we found the launch speed to be 11.66 meters per second. Applying the impulse momentum principle with the initial momentum equal to 0, the impulse of the foot on the ball is 1.75 newton-seconds, directed at 60 degrees above the horizontal. Visit doassignment.ca for more study tools, AI learning support, and online tutoring.